Hello everyone, I'm from Institute of Mathematics, Novosibirsk Academy of Sciences, one of the biggest scientific facilities, headed by great mathematicians, Sobolev, Godunov, academician Yershov. They have all been academicians, and academician Lavrentiev. Institute of Mathematics has a world-recognized mathematical schools, set of mathematical schools, and as far as the topic of my presentation goes, I would like to draw your attention to the fact that this institute has been working for more than 60 years, and we have a Siberian School of Artificial Intelligence in place. We know that the establishers, the fathers of the artificial intelligence, when they were creating artificial intelligence, were considering a few aspects of this new discipline. As science aspects, technology, and application systems, like creating application systems which would be capable of finding resolution to intellectual tasks. Unfortunately, the current state of artificial intelligence has slightly deformed that notion. These aspects have become distorted due to commercial interests involved. Of course, scientific interest does present here, but not to such great extent. Yes, earlier this year, our president addressed us in his speech that we need to have a breakthrough in artificial intelligence. And we have questions here. What do we have to find? Where do we have to find this breakthrough? Where and how should we look for this breakthrough, and who should be looking for this breakthrough? And this school of Siberia has come with supposed answers, the scientific understanding of how intelligence works and how it can be reproduced with machines, and the fundamental sciences should be finding a reasonable place there. And the answer of the question who should be looking for this breakthrough, it should be us, including the AI schools, and that's what I would like to talk about.
Because it's part of the strategic aspects of the AI development here in Russia. This way, you can ask a question. So what is an AI school? So I've tried to give an answer to this question in this slide. Of course, the school here comprises, in the first place, people who use the same methodology, who possess the same scientific knowledge and the skills to solve problems. It's all part of the concept of AI that is represented in this slide, both as a scientific component, technology component, and applied systems. So our understanding of AI is a certain discipline that allows solving practically important problems. As an example, I'd like to tell you how the Siberian Scientific School is organized. As to the methodology and philosophical aspects, so we have our own concept that we call problem-based approach to AI. As to the theoretical approach, this discipline consists of two subsections: mathematical theory, that's called semantic modeling, and empirical part, intuitive, that is basically about cognitive data analysis. As to technology and application aspects, we, together with our partners, do it jointly. And the outcome of this joint activity is in that several platforms were built. iLine, ECO's colleague platform called Beta System, and the AI system Semantic Discovery and Frizz. As to the applications developed with these technology tools, there are lots of them. And here you see the industries for which they have been built. Telecoms, fintech, healthcare, energy, retail, and so on. A few words about what's the essence of our methodology that we are referring to as problem-based approach. In order to talk about the problem-based approach, we need to answer several questions. Firstly, what is a problem? Where do you get problems? Why do they emerge? How they can be solved? And so on. In the following slides, I will explain what we mean by these terms. The problem is understood as, firstly, a semantic model of the subject area to which there's a request. But in order to make sense of a problem, we also need to have criteria of what can be the right answer to a request. And also, context is very important within which this problem is being solved. As to the context, it's the answers to the questions of why, what for, what are the implications of solving or not solving this problem, and so on. Now, regarding the taxonomy or classification of problems that our school shows interest to. All intelligent problems that we encounter in human development, we've split them in three groups. One of the most important groups is computational problems, and the history of automating such a problem solution is long. All the same, AI deals with other types of problems, such as reasoning or learning problems. And that's where AI is focusing the attention. Whenever we're talking about the automation problem, another problem comes up, how to solve hybrid problems that includes both computational aspects and also AI-related aspects, reasoning, planning, learning, whatever. So usually AI pays attention to this kind of tasks, reasoning, learning, planning, prediction, but we notice that computational aspects are also very important to solve problems. And we have tried to figure out what computational models are used by AI. And after detailed and deep analysis, we've arrived to the understanding that you can use the model that our mathematical logic school is strong in. That's model theory, which includes such disciplines as applied model theory, fuzzy model theory, enumeration theory, and this is the approach that we called semantic modeling. This slide shows the main publications that reflect this concept. Now, regarding the mathematical aspects and technology aspects. This slide and the next one show the steps that need to be taken according to our philosophy and methodology in order to solve problems of this class. So firstly, this all starts with content-based problem setting. Then we arrive at formalizing, converting it into mathematical terms. Then from mathematical terms, we convert it to computer terms. And then at the end, we get the final solution as an intelligent system. From the practical point of view, in the world where we formalize our problems in the computer world, you can observe the following. There's some initial model that needs to be perceived as a computer. And this model is enriched by a certain world that we call universal data models. So we use lists, some signature symbols related to the processing and such operations as to take an element of a list, to go to the beginning of the list to see if this item belongs to any of the lists, if any list is a sub-list of another list. So this is the list add-on that we build, and within which we start to formalize our problem. This slide offers a way for formalization, which is a platform, which is called Sigma Delta platform. It's where the subject area can be set as a delta zero model of the P signature of the list add-on as a set of delta zero definitions. These are the formulas where, as part of mathematical language, we can formalize our understanding of the subject area and the requests. As to the answers to the requests, it's looked for as a procedure to identify the truthfulness of the formula. So if the formula is understood to be true, then it means that it's a solution. As to the platform solutions, I have mentioned them in the beginning. Here they're listed. It's a platform that has been created by iLine. ESDP is a platform that is called Semantic Discovery. It's a platform that's been created by Irkutsk colleagues, B system, and a platform developed by Professor Zagoroyko and colleagues. The application areas are listed here. In some of them we already have successful experience, others are being studied, and we're hoping that our approach will be a success. With this, I'd like to wrap up the introduction of how we see the strategy of AI development and what the Siberian School of AI is about. Thank you for your attention.